So we are taking the chemical properties of the alcohols and that of the phenols. So in the last video we learned about the laboratory test for the phenols and that of the alcohols, and from that it is clear that phenol is weakly acidic in the aqueous solution and alcohol is neutral in the aqueous solution. So the next we have to consider the reactions due to breaking of OH bond. So as you know that when we consider the alcohols or that of the phenols, these are having ROH or the AROH bond. So in that section we are taking the breaking of this OH bond in the alcohols and that of the phenols. So in that case, first we are considering the acidic character of alcohols and that of the phenols. So as you know that the phenols are weakly acidic and the alcohols are neutral in the aqueous solution. Now, why phenols are weakly acidic and alcohols are neutral? So for that, to show the acidity and the neutrality of phenols and alcohols respectively, we have to consider the ionization of the OH bond which are present in the alcohols and that of the phenols. Now, when we are dissolving these alcohols and that of the phenols in the aqueous solution, there will be a breaking of OH bond in the alcohols and that of the phenols. Now, that process of ionization will be takes place. It means there will be a formation of positively charged ion and negatively charged ion. After a breaking, there will be, if there will be breaking of OH bond in the alcohol, there will be a formation of alkoxide ion which carries a negative charge, hydrogen carries a positive charge, and when there will be a breaking of OH bond in the phenols, there will be a formation of phenoxide ion and that of the H plus ion. Now, when we consider the ionization of alcohol in the aqueous solution, there will be a formation of alkoxide RO negative. Now, when there will be a formation of alkoxide ion, in that case, to this oxygen, on this oxygen there will be formation of negative charge, and to this oxygen there will be attachment of the carbon of the alkyl group. And when we consider the electronegativity of oxygen and carbon, oxygen is more electronegative than that of the carbon, and due to that what happens, there will be a positive inductive effect plus I effect. Due to that what happens, the electron density on the oxygen increases due to the positive inductive effect, and therefore alkoxide ion becomes less stable after ionization. Now, when we consider the phenol, in that case, when we are taking the aqueous solution of phenol, there will be a breaking of OH bond. After the breaking of this OH bond, there will be a formation of ion, that is the phenoxide ion. Now, this phenoxide ion, which is the conjugate base of the phenol, is stabilized by the resonance, because the phenoxide ion forms in which the oxygen carries a negative charge, and this negative charge on the oxygen is delocalized over the benzene ring, and therefore it stabilizes the phenoxide ion. So how there will be a resonating structures we are getting? So this of negative charge on the oxygen shifts here, and then the pi bond in the ring shifts here, therefore we are getting the second structure in which at this position there will be a formation of negative charge. Now this negative charge shifted in the benzene ring or converted into the pi bond, and pi bond shifted on the carbon to form a negative charge. So we are getting the third structure. In the third structure, this negative charge gets converted into the pi bond, and pi bond gets converted into the negative charge. Then we are getting the fourth structure. And in the fifth structure, this negative charge gets converted into the pi bond, and pi bond gets converted into the negative charge which is on the oxygen. So we are getting the 5 resonating structures, and these 5 resonating structure stabilize the phenoxide ion, and therefore the phenol is acidic, weakly acidic, and the alcohol is neutral, because when we consider the phenol, after ionization, phenoxide ion is formed, which is stabilized by the resonance. It is the conjugate base of phenol. But when we consider the ionization of alcohol in the aqueous solution, there will be a formation of alkoxide ion, which gets destabilized due to the positive inductive effect of the alkyl group, and therefore it is neutral. Alcohol is neutral in the aqueous solution, and the phenol is weakly acidic. Now the second is the esterification. So in the esterification, there will be a formation of esters from the alcohols. Now from the alcohols, we can convert the alcohols into the esters by using the carboxylic acid. Second, by using the acid anhydrides, and third one by using the acid chlorides. So these are the three reagents by which we can convert the alcohols into the esters. Now the conversion of alcohols into the esters by using the carboxylic acid is called the esterification. The reaction is ROH, that is the alcohol, when reacts with the carboxylic acid, it gives the esters. Esters are having the formula ROC double bond O R dash. Now in that case, there will be a breaking of OH bond in the alcohol, and there will be a breaking of carbon oxygen bond in the carboxylic acid by the removal of H2O molecule, and then this RO gets attached to this carbon to form a ester and that of the water molecule. Now this reaction we carried out in the presence of concentrated sulfuric acid. So we have to carry out this reaction in the acidic medium. When we are considering the reaction of phenol with the carboxylic acid in the presence of concentrated sulfuric acid, it gives the corresponding ester. But in both the reaction, the byproduct form is the water, and this reaction is reversible, and therefore when we want to shift the equilibrium towards the right hand side, that means if we wanted the more product, in that case we have to remove the water molecule as soon as it is formed, because if we are not removing the water molecule as soon as formed, it reacts with the ester, and that ester gets converted into the alcohol and that of the acid. So when you are converting the alcohols into the esters by using the carboxylic acid, you have to take the precaution, as soon as the byproduct water molecule is formed, you have to remove it from the reaction mixture, otherwise the reaction becomes reversible and the product obtained will be a less. Second reagent that we can use to convert the alcohols into the esters is the acid anhydride, having a formula R dash C double bond O O C double bond O R dash. Now in that case also there will be a breaking of oxygen hydrogen bond in the alcohol, and there will be a breaking of bond between the carbon and oxygen. Now that gets RO C double bond O R dash. This reaction also carried out in the presence of acid. Then there will be a formation of ester and that of the carboxylic acid. In the same way, when we carried out the reaction of phenol with the acid anhydride, it gives the ester and the carboxylic acid. So that is the reaction with the acid anhydride. Third reagent that we can use to convert the alcohols into the esters is the acid chlorides. So when this alcohol treated with the acid chlorides in the presence of pyridine, it gives the ester and that of the HCl. Now when phenol reacts with the acid chloride in the presence of pyridine, it gives the ester and that of the HCl. Now in both this reaction, when we are using to convert the alcohol into the esters by using the acid chloride, the byproduct form is the HCl. Now in that case we are using the pyridine, which act as a base, and this base neutralizes this acid, and therefore this is one of the important method to convert the alcohols into the esters by using the acid chlorides, because this pyridine neutralizes the byproduct HCl. Now next, acetyl derivatives. so which is called the acetyl group. CH3CO group is called the acetyl group, and the which are called acetyl derivatives, the product of the alcohols and phenols which form the esters with the acetyl group in the with acetyl group are called the acetyl derivatives. So in that case, when we consider the acetyl derivatives, so for example, if we are considering the reaction of salicylic acid having a formula C6H5COH to the acetic anhydride, then in the acidic medium it gives the acetyl salicylic acid, that is the acetyl salicylic acid, and that of the acetic acid. Now in that case, there will be breaking of OH bond, and then there will be breaking of bond between C double bond CO, then the C double bond O CH3 gets attached to this to form a ester. That is, the name of that ester is the acetyl salicylic acid. Now, and the second product is the acetic acid. Now in that case, there will be a insertion of the acetyl group in the alcohol, in the phenol, and therefore these are called the acetyl derivatives. Now if you find the name of that compound is the aspirin, which is the generic medicine which is used in the treatment of various medicinal uses. Now such type of compounds are called the acetyl derivatives. So the insertion of CH3CO group in the phenols and that of the alcohols is called the acetyl derivatives. Now this is one of the important method, that is the acetyl derivatives are used to find out how many hydroxyl groups are present in the phenols or that of the alcohols, and that we can know how many acetyl groups are inserted in the product. By counting that, we can find out the how many OH groups are present in the phenols or that of the alcohols. For example, in this example there will be only one OH group, and therefore, and in the product side we are obtaining the product which contains only one acetyl group. By observing this product, we can say that the given phenol having only one OH group, because there in the product side there will be only one acetyl group. So by counting the number of acetyl groups, we can find out the how many OH groups are present in the given phenol or in the given alcohol.